Welcome to NSMO, the National Science and Mathematics Olympiad. In this lesson, we will study an important topic related to atomic structure called exceptions in electron configuration. While most electron configuration follow the Aufbau principle, there are well-known and important cases where atoms behave differently. Understanding these exceptions helps explain atomic stability and real experimental observation. According to Aufbau principle, the electrons fill atomic orbitals in order of increasing energy. The general filling order is 1s, 2s, 2b, 3s, 3b, 4s, 3d, 4b. Based on this rule, we would normally expect electron to completely fill the 4s orbital before entering the 3d sublevel. For many elements, this rule works well. However, for some transition elements, experimental data shows different configurations. Why do exceptions occur? The exceptions occur because certain electron arrangements are more stable than others. In particular, the d sublevel is especially stable when it is half-filled or completely filled, d5 and d10. Atoms sometimes rearrange their electrons slightly to achieve this more stable configuration, even if this means violating the expected Aufbau order. The d sublevel is more stable when it is half-filled with 5 electrons or fully filled with 10 electrons. To achieve this stability, an electron may move from the 4s orbital to the 3d orbitals. We start with the first exception. Exception number 1. The chromium, Cr. Let us examine a chromium which has an atomic number of 24. Expected configuration based on Aufbau. Following the Aufbau principle, we would expect chromium to have argon 4s2 3d4. But the actual configuration observed, however, chromine 4s1 3d5. Explanation: a chromium shifts one electron from the 4s orbital to the 3d orbital. This results in a half-filled 3d sublevel d5, which is more stable, slightly lower energy for the atom overall. Therefore, the chromium is an exception to the Aufbau principle. Exception 2. Copper, Cu. Now let us consider copper, which has an atomic number of 29. Expected configuration based on Aufbau, according to Aufbau, is going to be Cu argon 4s2 3d9. But the actual configuration, which is observed, Cu is argon 4s1 3d10. Explanation: copper moves one electron from the 4s orbital to the 3d orbital, resulting in a completely filled 3d sublevel d10, which is highly stable, a lower overall energy state for an atom. This makes copper another classic exception to the Aufbau principle. Important notes about these exceptions. These exceptions occur mainly in transition metals element. They involve small energy differences between the 4s and 3d orbitals. Stability of half-filled and filled d orbitals outweigh strict Aufbau filling. Once the atom forms ions, the 4s electrons are lost first, even though they are written before 3d in the neutral atom configuration. Let us now move to the exercise. In this exercise, asking to write the electron configuration for the atoms of the following elements. Chromium, atomic number 24, and the copper, the atomic number 29. We start with the chromium, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5, or we can write it as argon, 4s1, 3d5. For the copper, Cu, argon, 4s1, 3d10. Summary: most elements follow the Aufbau principle, but chromium and copper are important exceptions. Their actual electron configuration are explained by the extra stability of half-filled and fully filled d sublevels. Recognizing these exceptions is essential for correctly writing electron configuration and understanding atomic behavior. Thank you, with my best wishes for success.